Hello everyone, welcome back to my YouTube channel Physics Unification. In the last video, we discussed two chapters from first PUC, Physical World and Units and Measurements. Today, we are going to deal with the third chapter, that is Motion in a Straight Line. These are main contents we are going to study in the upcoming videos. Introduction part, position, path length and displacement, average velocity and average speed, instantaneous velocity and instantaneous speed. What do you mean by acceleration? Kinematic equation for uniformly accelerated motion, and at the finally relative velocity. First of all, what do you mean by motion? It is a change in position of an object with respect to time. If you consider an object which changes its position with respect to time, then we can said to be that object is in motion. That object is moving along the straight line, then that is known as rectilinear motion, means straight motion. Let us consider example of car which is moving in a straight line. Here, who is the origin of the car? Origin position of the car, P, Q, R are the different positions at a different time. Let us define what do you mean by path length depends on position of the car. Path length means length of the actual path traveled by a body. ಒಂದು ಬಾಡಿ ಎಷ್ಟು ಆ್ಯಕ್ಚುಯಲ್ ಪಾತನ್ನು ಕವರ್ಡ್ ಮಾಡ್ತದಲ್ವ ಆ ಲೆಂತನ್ನು ನಾವು ಪಾತ್ ಲೆಂತ್ ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. ಸೊ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ if that car which is at the position P from the origin O and which returns at the position Q from the point P, then how we have to write path length for this position of the car? OP means OP which is equals to 180 meter and which is returns from P to Q. It becomes total length of the car is equals to OP plus PQ. OP is equals to 180 meter plus PQ is equals to 180 minus 120 is 60 meter. Total path length covered by that car is equals to 240 meter. Then how we can define displacement of that car? Displacement can be defined as change in position of a body in a specific direction, in a particular direction. Let us consider car movement from O to P, then that is origin to point P. That one is equals to 180 meter, and delta x can be taken it as displacement in time, delta t, that one is t2 minus t1. Delta x can be written as x2 minus x1. X1 is original position, that one is at O. 180 minus 0 is equals to 180 minus delta x is equals to x2 minus x1. X1 is the original position of that car. 180 minus 0 is equals to 180 meter. Then displacement of car from P to Q is Q position which is at 180 meter minus P position which is at 180 meter. 120 minus 180 is equals to minus 60 meter. Therefore, at the finally we conclude it as magnitude of displacement 60 meter, that is not equal to the path length, that one is 240 meter. So let us consider difference between path length and displacement. This difference is very important for 2 marks for the final first PUC examination. Path length and displacement. Already we know first point, that one is definition of both the quantities. What do you mean by path length? That one is length of the actual path traveled by a body. First point it's over. In displacement, change in position of a body in a specific direction. So how now let us consider second point. In path length, it is depends on the path. That one is actual path. And it is independent of path. Which one? Displacement. Here path length it is scalar quantity. Then what do you mean by scalar quantity? Scalar quantity means it has only magnitude but not direction. But displacement, which is vector quantity, means it has both magnitude and direction. Here path length can be 0 or positive, but it cannot be negative. But displacement can be positive or negative. This one is the fourth main point. Last point it is, for a moving body, it can never decrease with time but only increases. In case of displacement, for a moving body, it can decrease or increase or remain constant with respect to time. These are the main differences between path length and displacement. Next concept is average velocity and average speed. We already know velocity means displacement divided by time taken. That one is change in position divided by time interval. Average velocity is equals to change in position divided by time interval. Change in position can be written as x2 minus x1 divided by t2 minus t1. x2 minus x1 can be written as delta x divided by delta t. Then what do you mean by average speed? Average speed is the total path length divided by total time interval. Means speed depends upon path length, velocity depends upon displacement. Next concept it is instantaneous velocity and instantaneous speed. This one is very important for 1 mark for the final examination. Then what do you mean by instantaneous velocity? It can be defined as limit of the average velocity as the time interval delta t approaches 0. Means when delta t is very small or which is approaches to 0, that limit of the average velocity gives the instantaneous velocity delta x by delta t when it is limit delta t tends to 0, which gives dx by dt. This is known as instantaneous velocity. Here instantaneous speed is the magnitude of instantaneous velocity. Next concept it is acceleration, average acceleration and instantaneous acceleration. Then what do you mean by acceleration? We already know acceleration is equals to velocity divided by time taken. SI unit for acceleration is, for velocity meter per second, for time it is second. So SI unit for acceleration is meter per second square. This one is the SI unit for acceleration. And in the similar way, dimensional formula is m0 L t minus 2. That is Lt minus 2 is the dimensional formula for acceleration. Next concept it is average acceleration. Then what do you mean by average acceleration? It is change in velocity divided by time interval. Now instantaneous acceleration can be defined as, this one is also important for 1 mark for final examination. It is defined as the limit of the average acceleration as the time interval delta t approaches 0, means which is very small. Acceleration, instantaneous acceleration is equals to limit of dv by dt when delta t tends to 0 is equals to dv by dt. Sorry, that is limit of delta t tends to 0, delta v divided by delta t is equals to dv by dt. Next one it is position time graph. That one is xt graph of one object, or that one is pt graph. What this pt graph refers when we take position along y axis and time along x axis, which can be referred as pt graph, position time graph. First case of that pt graph is when object is at rest, means which is in rest position, rest moment. That means it does not have any moment. Then position which is parallel, position line which is parallel to the timeline. This one is the first graph for the object when which is at rest position. Second case, when object is moving with uniform positive velocity. Positive means upper position of object. Then as it is, time increases, position of that object is also goes on increases. This one is the second graph when object is in moving with uniform velocity. Third graph it is when object is moving with increasing velocity, that is positive acceleration. Here it is uniform positive acceleration, positive velocity. Therefore, we will get it as straight line, which is increasing as time increases. This graph is refers to for increasing velocity. Increasing velocity means positive acceleration. We will get graph like these. Parabola type, half parabola type. P along y-axis, T along x-axis. At the last, when object is moving with decreasing velocity, that is negative acceleration, then we will get, as time increases, position of that object is changes. At certain time, it becomes constant. That one is for decreasing velocity. Next concept is difference between speed and velocity. This difference is also important for 2 marks for the final examination. Then we already know difference between speed and velocity. First definition, we have to write it as definition for both the quantities. First point. So first point it is for speed, which is distance moved by a body per unit time. In case of velocity, it is displacement of a body per unit time. That in case of speed, distance per unit time. In case of velocity, it is displacement per unit time. Speed is depends on path length, so it is a scalar quantity. Scalar means it only has magnitude but not direction. Velocity, it depends upon displacement, so it is a vector quantity. Means it has both magnitude and direction. In case of speed, it can be 0 or positive but cannot be negative. In case of velocity, it can be 0, positive or negative. Next one, it is velocity time graph. Here, when velocity is floated along y-axis and time floated along x-axis, then that graph termed it as velocity time graph. While drawing velocity time graph, there are 3 main cases, and this graph is very important for 2 marks for the final examination. Then how to draw those cases? Let us see. First case, it is when the body is moving with uniform velocity. Uniform means constant velocity. What it happens in this case? See, as time increases, velocity is constant, means that one is parallel to the x-axis in this case. In second case, when a body starts from rest position and moving with uniform acceleration. Uniform acceleration means constant acceleration. As time increases, velocity also increases in this case. And third case, it is when body is moving with uniform retardation. Retardation means negative acceleration. In this case, what happens? As time increases, velocity goes on decreases, and finally which reaches or intersects at the x-axis. These are the three main cases while drawing velocity time graph. Now next one, it is velocity time graph. When velocity is floated along y-axis and time along x-axis, that gives velocity time graph. In this case, there are three main possibilities are there. First one, it is when body is moving with uniform velocity. In this case, what happens? As time increases, velocity remains constant. It does not change. Uniform velocity we will get. This one is the first case. In the second case, when body starts from rest and moving with uniform acceleration. Here what happens? As time increases, velocity also increases. This one is the second case. In the third case, that one is when body is moving with uniform retardation. Uniform retardation means negative acceleration. Here what happens? As time increases, velocity goes on decreases, and which reach or which intersects at the one particular point on the x-axis. These are the main three cases while drawing velocity time graph, and this one is very important for 2 marks. Next one, it is kinematic equations for uniformly accelerated motion, and this one is very important for 5 marks. Let us consider an object starts with initial velocity v0 at x0 equal to 0 at a time t equal to 0, moves with a constant acceleration a, and final velocity of the object be v after time t, and x be the displacement of the particle. First of all, we have to derive first equation. That one is v is equals to v0 plus at. Here v means final velocity, v0 means initial velocity of the particle, a is acceleration, and t is the particular time. How we have to find out the value of a? A means acceleration is equals to slope of the graph. Slope is equals to, just by seeing this triangle, slope is equals to BC by AC. BC by AC. Therefore, acceleration is equals to, value of BC is equals to final velocity minus initial velocity. That one is V minus V0. V minus V0 divided by AC, which is equals to the value of OD. OD equal to T. So A into T is equals to V minus V0. So therefore finally we will get V is equals to V0 plus AT, because V0 which is on right hand side, just by interchanging the sign we will get V is equals to V0 plus AT. This one is the final expression while deriving the derivation. Second one, we have to derive x is equals to v0 t plus half at square. Here while deriving this one, how we have to write? Displacement x. By the graph, displacement can be written as area under Vt graph, that is displacement x is equals to area under Vt graph means area of trapezium OABD. Area of trapezium OABD. Here trapezium OABD, which consists of two. One it is triangle, another one it is rectangle. So trapezium area can be split into two parts. That one is area of rectangle OACD plus area of triangle ABC. ABC. Area of rectangle, that one is length into breadth. Here rectangle, let us consider OA, it is the rectangle. Length it is OD, breadth it is OA. Length into breadth plus area of triangle, it is half into base into height. Half into base it is AC, height it is BC. AC into BC, which is equals to x is equals to value of OD is equals to T into value of OA is equals to V0 plus half into value of AC, which is nearly equal to value of OD, that one is into T, into value of BC is equals to V minus V0, because AC is equals to OD and which is equals to T. In equation 1, we will get value of V minus V0 is equals to A into T. Just to substitute value of V minus V0 is equals to A into T in this expression. Then we will get x is equals to V0 T plus half V minus V0 is equals to A into T by the equation 1 expression. A into T, here already T is there, that one is T. The value of x is equals to V0 T plus half AT square. This one is the second kinematic expression. Next, to derive third kinematic expression, it is V square is equals to final velocity square is equals to initial velocity square plus 2ax. Here displacement of the body in time t is equals to area under VT graph, that one is area of trapezium OABD. Area of trapezium OABD. How we have to write? Half into base it is O into D and height it is OA plus BD. OA plus BD. OA plus BD, which is equals to half into value of OD is equals to value of OD is equals to T into value of OA is equals to V0 plus value of BD is equals to final velocity V, which is equals to half into, by the equation 1, A is equals to V minus V0 divided by T. This one is the expression in equation 1. Just by looking at this equation, we can write value of T as V minus V0 divided by A. So it becomes V minus V0 divided by A into V0 plus V, which is equals to 1 by 2A V minus V0 into V0 plus V. Displacement x is equals to 1 by 2A. We know the one more expression, A plus B into A minus B is equals to A square minus B square. That is, it should be like this, V square minus V0 square. Then this expression becomes V square minus V0 square, which is equals to V square is equals to V0 square plus 2ax. That is v square is equals to v naught square plus 2ax, and this one is the final kinematic expression, and total derivation is carried for 5 marks for the final examination. Next concept, it is velocity, relative velocity. Then what do I mean by relative velocity? Velocity of one object with respect to velocity of another. Let us see example or experience of relative velocity in day-to-day life. Let us consider we are traveling in a train and being overtaken by another train moving in the same direction. While the train must be traveling faster, but it seems slower to us than it would be someone standing on the ground and watching both the trains. So in other case, what happens when both the trains have the same velocity with respect to the ground, then to us the other train would seem to be not moving at all. In those cases, we can see concept of relative velocity. ಅಂದ್ರೇನು, ನಾವಿವಾಗ ಟ್ರೈನಲ್ಲಿ ಮೂವ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅಂದಾಗ ಮತ್ತೊಂದು ಟ್ರೈನ್ ನಮಗೆ ಓವರ್ಟೇಕ್ ಮಾಡಿಕೊಂಡು ಹೋಗ್ತದೆ. ಆ ಟೈಮಲ್ಲಿ ಏನಾಗ್ತದೆ, ಆ ಟ್ರೈನ್ ಯೂಶ್ವಲಿ ಫಾಸ್ಟ್ ಇದ್ದರೂ ಕೂಡ ನಮ್ಗೆ ಏನು ಎಕ್ಸ್ಪೀರಿಯೆನ್ಸ್ ಆಗ್ತದೆ, ಆ ಟ್ರೈನ್ ಸ್ಲೋವಾಗಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅನ್ನೋ ಥರ ಫೀಲ್ ಆಗ್ತದೆ, ಎಕ್ಸ್ಪೀರಿಯೆನ್ಸ್ ಆಗ್ತದೆ. ಮತ್ತೊಂದು ಕೇಸಲ್ಲಿ ಏನಾಗ್ತದೆ, ಎರಡೂ ಟ್ರೈನ್ ಕೂಡ, ಅಂದರೆ ನಾವು ಕೂತ್ಕೊಂಡಿರೋ ಟ್ರೈನು ಮತ್ತು ನಮಗೆ ಓವರ್ಟೇಕ್ ಮಾಡ್ತಿರೋ ಟ್ರೈನು ಎರಡೂ ಕೂಡ ಸೇಮ್ ವೆಲಾಸಿಟಿ ಒಳಗೆ ಮೂವ್ ಮಾಡ್ತಾ ಇದ್ದಾಗ ನಮಗೇನು ಅನ್ನಿಸ್ತದೆ, ಆ ಟ್ರೈನ್ ಮೂವ್ ಮಾಡ್ತಾನೇ ಇಲ್ಲ, ಕಾನ್ಸ್ಟೆಂಟಾಗಿ ನಿಂತ್ಕೊಂಡಿದೆ ಅಂತ ಫೀಲ್ ಆಗ್ತದೆ. ಈ ಕೇಸಸಲ್ಲಿ ನಮಗೆ ಏನು ಎಕ್ಸ್ಪೀರಿಯೆನ್ಸ್ ಆಗ್ತದೆ, ರಿಲೇಟಿವ್ ವೆಲಾಸಿಟಿ, ಅಂದರೆ ವೆಲಾಸಿಟಿ ಆಫ್ ಒನ್ ಆಬ್ಜೆಕ್ಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿ ವೆಲಾಸಿಟಿ ಆಫ್ ಅನದರ್ ಆಬ್ಜೆಕ್ಟ್ ಕ್ಲಿಯರ್ ಆಗ್ತದೆ. ಆ ಕಾನ್ಸೆಪ್ಟ್ ಯಾವುದು, ರಿಲೇಟಿವ್ ವೆಲಾಸಿಟಿ. ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಟು ಆಬ್ಜೆಕ್ಟ್ಸ್, that is train A and B moving along a straight line with constant velocity VA and VB. Then the relative velocity of A with respect to B is VA minus VB. Similarly, relative velocity of B with respect to A is VB minus VA. If what happens when A and B are moving in the same direction, then that relative velocity becomes 0. That's why we are experiencing other train seem to be not moving at all. So here which contains 3 more graphs. That one is PT graph of two objects with equal velocity. PT graph means position along y-axis and time along x-axis. As it is time increases, what happens in this case, if both the objects having the equal velocities, both the graph becomes increases as time increases. In the second case, PT graph of two objects with unequal velocity. Different velocity means two objects moving with different velocities, showing the time of meeting at t is equals to 3 seconds. X along y-axis, t along x-axis. At particularly time t equal to 3 seconds, both the objects will meet each other. In third case, that one is PT graph of two objects moving in opposite direction, showing the time of meeting at 1 second. Position along y-axis, time along x-axis. At particularly t equal to 1 second, we can consider two objects will meet each other. This completes the chapter Motion in a Straight Line. I hope you understood these concepts. If you have any doubts regarding these, please ask me in comment box. Thank you. Stay tuned. Like, share and subscribe Physics Unification channel. Thank you.